So under chemistry there, you were looking at acid bases and what? Salts, isn't it? And you looked at what an acid is. Devil, we said an acid, it is a substance that produces what? Hydrogen ions when dissolved in what? Water. What makes acids to be sour? It's because of what? The hydrogen what? Ions. There are strong acids and there are also weak what? Acids. Strong acids are the ones that are completely what? Ionizes to produce hydrogen what? Ions. While it's bases, we said bases, they produce what? Hydroxide what? Ions. So these ones they produce hydroxide, my bases, but my acid they produce what? Hydrogen. Now, Mr. Wembe told me that you people learned about the solubilities. Soluble salts, insoluble salts, Mr. Wembe told me. So we'll just go back a bit before I go to what I want to explain. According to the solubilities of salts there on the table, there on the papers that I've given you, but all nitrates are what? Soluble. All the nitrates. There are no nitrates that are soluble. In short, when I have something like this, which is KNO3, what name is given to this? What name is that compound there? Oh? No. Potassium. Very good. Potassium what? Nitrate. Is potassium nitrate soluble or insoluble? You don't understand what it means to be insoluble. Why? Yes. Something which is insoluble is something that is not able to dissolve in what? In water. And it exists in what? In solid what? State. Something which is soluble is something that is able to dissolve in what? In water. But there are some that are found in solid state, but they are able to dissolve. But in here, something which is insoluble is something which is solid and cannot dissolve in what? In water. So now, is potassium nitrate soluble or insoluble? It is what? Very simple. Nitrates, solubilities. All nitrates are what? Soluble. Is potassium nitrate soluble or insoluble? Soluble. Simple. Soluble. Anything that contains nitrate in it, they are what? Soluble. Otherwise, good exercise, the one that is coming, there's somewhere where we're supposed to be using now these compounds. We identify them, but we identify something which is what? Soluble. Okay? So even though we went to calcium nitrate is like this, isn't it? You remember how to form Devil? Is calcium nitrate soluble or insoluble? Soluble. Very good. All nitrates, anything, any that contains a nitrate, they are all what? Soluble. Very good. We proceed. Then we come to say chlorides. All chlorides are soluble except a silver, AgCl, and also what? Lead, PbCl2. What are these? Are these soluble or insoluble? Insoluble. They are insoluble. But what if I say KCl, then also FeCl3? Are these soluble or insoluble? Insoluble. They are what? Insoluble. They are soluble. Your biology, and they are soluble. Very good. These are what? Soluble. The only insolubles that are there are what? Silver and what? Lead. When they contain what? Chloride. The only chlorides that are insoluble in short is silver and what? Lead. But the rest of the chlorides, they are all what? Soluble. Okay. Then we come to sulfates. All sulfates are what? Soluble, except again the barium. Barium what? Sulfate. Apart from barium sulfate, there is what? Leads to what? Sulfate. What are these? These are what? Insoluble. These are the only insoluble sulfates that are there, and even calcium sulfate, but it is slightly what? Soluble. So if we say copper 2 sulfate, is copper 2 sulfate soluble or insoluble? Soluble. Soluble, insoluble. Soluble. Secretary. Copper 2 sulfate. It is soluble. The only insoluble sulfates that are there is what? Barium sulfate and what? Lead 2 sulfate. The rest of them, they are what? Soluble. Apple. Who's what apple? Carbonates. All carbonates are insoluble except ginger. What if I have this calcium carbonate? Is it soluble or insoluble?
Soluble.
Voila. So let's understand. Oh, Bagamachani, all carbonates are what? Insoluble, except what? Potassium carbonate. What else is potassium carbonate? Sodium carbonate. Apart from sodium carbonate, there's also what? Ammonium carbonate, NH4, then 2CO3. Consider that. What are these? Are these solubles or insolubles?
Solubles.
Very good. These are solubles. Is calcium carbonate insoluble or soluble?
Insoluble.
Very good. Insoluble, which is what? A solid. This one exists as a solid because it is insoluble. Okay. Now pagawapa. We are safe for then we come to the types of salts that are there. There is what you call hydrated what? Salt. Again, upon kuziba. Can you define and can you give an example for an hydrated what? Salt. Hydrated salt, it is a type of salt that contains what? Water. And what we call that type of water that the salt contains, we call it as what? Water of what? Crystallization. An example of a hydrated salt is what? Those ones there. Copper 2 sulfate 5 what? Waters, which is CuSO4 dot what? How many waters? 5 of them. H2O. What is this? This is an example of what? Hydrated what? Salt. Why is it hydrated salt? Because it contains what? Water. And what we call the water that this contains is what we call water of what? Crystallization. So you should know examples of hydrated salt. But there is a question in Mukata fluid so that comes under this. Hydrated, anhydrous salt, a fluorescent, those things, very important. So this is hydrated salt. Why? Because of what? When I remove water from here, when we evaporate water from here, it becomes copper 2 sulfate plus H2O. What type of a salt is this? This one now becomes what? Anhydrous salt. When the water is there, it is what? Hydrated. When the moment I remove water, it becomes what? Anhydrous what? Salt. So anhydrous salt is a salt that does not contain what? Water. But if I add water to anhydrous salt, it becomes what? Hydrated salt. We are safe? Okay. Let me read through. This is a salt that contains water of crystallization. They contain a fixed amount of water in their crystal lattice. This is called water of what? Crystallization. The water of crystallization is a part of the structure. If this water is removed by heating, for example, the color and the shape of the crystals may what? Change. That's what we have. So here you should know. And sometimes the question comes to define water of what? Crystallization. Questions are there. You see, I'll surprise you. I'll give you a miracle. Examples of hydrated salt is what? Copper 2 sulfate 5 water, sodium carbonate 10 water, cobalt 2 chloride 6 water, and iron 2 sulfate 7 what? Water. And this is one of example. As long as by dot 5 dot H2O, that means that this contains what? Water. There's some water that are trapped in the crystal what? Lattice. But we can evaporate by heating. After I heat it, what will happen? Water will be what? Evaporated. Water that what does it mean? It means that this now changes the shape and the name. The name comes to what? Anhydrous salt. So anhydrous salt is a salt that does not contain what? Water. It's not a dry salt. It's called what? Anhydrous. While it's a wet salt with some water inside in the crystal lattice is called what? Hydrated what? Salt. A salt which has lost its water of crystallization is called anhydrous what? Salt. When water is added to anhydrous salt, the salt becomes what? Hydrated. Simple. If we add water to copper 2 sulfate plus H2O, then it means that this one contains water. Then it becomes what? Hydrated. If we remove water, it becomes what? Anhydrous salt. Yes. Very good. There are examples there, even this example is even there. Copper plus this is equal to that, and then the vice versa, it is there. Then there's what we call also efflorescence. This is the loss of water of crystallization to the what? Atmosphere. An example of an efflorescence is what? Sodium carbonate in water become powdery when exposed to what? To air. That is what we have. Then there's what we call what? Delinquency there. This is the absorption of water from the atmosphere to form a solution. Calcium chloride is a delinquent what? Salt. Up again, mfuneka kuziva delinquent salt ni chani. Pasami pasa chape, kamline chape, kama salt chambili chape. Then they'll ask you questions. Which of the following is a what? A for instance, which one is a what? Delinquent. It's there. I'm going to I'll show you. I'll show you. Don't worry. I'll give you a miracle question. It is used as a drying agent in what? Desiccators. A desiccator is a piece of equipment used to dry what? Substances. Hygroscopic, again a weight here. Very important weight. Mupange chape kanimbo chape mwenda mwimba hygroscopic delinquency mavakati mindset. It's okay. A hygroscopic substance absorbs water from the air but does not change its what? Its state. So a salt that absorbs water and does not change its state is called what? Hygroscopic. It absorbs water but does not what? Change. More like you absorb, you eat but you don't change. You don't sumaina, sumayonda, uchabe, soche koto sachabe. You are hygroscopic. Human being. Anhydrous cobalt chloride is also what? Have you seen ka? So apo palienangu they both fall under what? Anhydrous and also what? Hygroscopic. Like for example what? Cobalt what? Cobalt chloride. Cobalt chloride is also an what? Anhydrous salt, but it also falls under what? Hygroscopic what? Salt. Now let's go now to the preparation. The main lesson that I want there now. Okay. Now, on the main lesson there, what I want. Okay? There's something that I want. There's a preparation of what? Salt. Mean that we're looking at preparation of what? Insoluble what? Salt. Okay. The process by which insoluble salt. So we're talking about preparation. Mukonga, mtikongana. But my exercise, but my examples, example 1, example 2, example. My example to be Vasala is your own. Preparation of what? Insoluble. Insoluble what? Salts. Now, insoluble salts are prepared by the method called what? Decomposition, or what we call precipitation. So, insoluble salts are prepared by the method called precipitation. How can you prepare insoluble salts? So, you should know there are some salts, there are two types of salts. There's something which is soluble and there's something which is what? Insoluble. Now, how can you prepare insoluble salts? You prepare them by the method called what? Precipitation. How is this process done? You get something which is what? Soluble. React it with another thing which is what? Soluble. What you're going to get something which is what? Insoluble. And you're also going to get something which is what? Soluble. Simple as that. You react, you get two salts that are soluble, mix them together. Then those, when you mix them together, as you are stirring, they're going to form something which is what? Insoluble. And again something which is what? Soluble. Now, how do you separate them? You're going to separate them by the process called what? Filtration. We're interested in this insoluble, not the what? The soluble salt. We're interested in the insoluble and not soluble. So we are going to get rid of this by filtering off. Now let's go to them. And what is the example there? Example, preparation of what? Can you tell me that? Preparation of what? Silver what? Chloride. So what does it mean? That it means that silver chloride, it is an what? Is it insoluble salt or soluble salt? It is what? Insoluble. Now, how do you prepare? So we need a salt that is what? Soluble, plus another salt which is what? Soluble. But what is going to give us? To give us something which is what? Silver chloride, plus another soluble. We don't know, but we know the answer, the outcome. We know that this is the salt that we're preparing. So we're going to produce this salt. Now, what can we react in order for us to get this? Now, you're going to find a salt that is soluble, but that contains what? Silver. And another salt that is soluble, that contains what? Chlorine. Then you're going to react them together. So can you tell me those salts now? My reagents, man. What reagents are you going to use? You go back to every table. From a soluble salt, soluble, insoluble. We said all nitrates are what? So we can use what? We can use silver what? Silver nitrate. It's simple. So the reagents there that we're going to use, reagents, we identify the reagents. What are we going to react? One of them is what? Silver. Silver what? Nitrate. Why silver nitrate? Because silver nitrate is what? Soluble. We need something which is soluble that contains what? Silver. And we need something which is soluble that contains what? Chloride. Simple. Let's go again. Which other one can we react? But the one which we are reacting should contain what? Chloride. Which one is that? Under chloride. Check under chloride. But all chlorides are what? Soluble. Except what? Silver and what? Lead. So can you tell me any other compound which contains chlorides that you know? Any. Very good. Calcium what? Chloride. Or we can also use what? Sodium if you want. Sodium what? Chloride or calcium chloride. It's okay. So now these two, this is the AgNO3 and this is what? NaCl. These are the two reagents that we want. According to what I explained at one point, we said AB plus CD, the answer is A goes with what? D. So we get AD plus C goes with what? B. Let's react now. We're reacting what? Silver nitrate and also what? Sodium chloride. So we get silver nitrate plus, this is aqueous because it is soluble, it is aqueous. Plus, what are we reacting in? Sodium chloride. It is also what? Aqueous because it is soluble. What happens? The silver goes with what? Chlorine. A9. We get silver what? Chloride, which is what? Solid because it is what? Insoluble. Plus and the other one we're getting sodium react with what? Nitrate to give us what? Sodium nitrate. What is sodium nitrate? Is it soluble or insoluble? Soluble. So it is what? Aqueous. This is how you prepare, and this is the equation. So by example, they'll tell you to say silver chloride is an insoluble solid prepared in the laboratory by precipitation. Can you mention two reagents that can be used to prepare what? Silver chloride? You should identify. That's why ukatepo kama solubles, insolubilities, you're supposed to know it by what? By heart. So this is the equation here. It is already even balanced there. Then after that, we can come up with an ionic equation. Ionic equation, we're going to have silver, it is in aqua, so it will be what? Ag plus, then NO3 what? Minus, which is still aqueous. Plus, sodium is what? Na. What is the valence of sodium? 1. Meaning that it is able to what? To lose. Yes. Then chlorine is able to what? To gain. But it is still aqueous. It's able to. Do those in solid, liquid, and gas, do they change? No. They remain unchanged. So it will be ClAgCl, which is solid, plus Na positive, NO3 what? Negative, which is aqueous. We cancel the spectators. Okay? Ag plus. Do you have Ag plus there? No. NO3 negative. Do you have NO3 negative? Yes. This and this out. Na positive. Do you have Na positive there? Yes. This and this. What am I going to remain with? Ag plus, which is still what? Aqueous. Plus what? Cl negative, which is still what? Aqueous. Is equal to what? AgCl solid. This is the net ionic equation. I'm not done. How then the equation comes to say, explain. For example, explain how pure dry samples of silver chloride can be what? Obtained. Now, method number 1. What do? Mix. But mix the two soluble salts in a what? Beaker. Man, do not say that mix the two soluble salts into the beaker. Mention the name. So you say mix what? Silver. Mix silver what? Nitrate and sodium chloride in a what? Beaker and what? Stir. So it means mozi mubika muli silver. Then kutukula inango pouring there. As you are pouring there, what are you doing? Stirring. As you are stirring, what will happen? Some insolubles are going to be what? Formed, but there will be some solubles and what? Insolubles. That's how it is. Then what you do? Step 2, what? Allow the what? The precipitant to do what? To say to David. What is the next step? You have one method. Allow the precipitant to do what? To settle. So allow the PPT to what? To settle. After settle, what have they said? Filter. Very good. Ulina abiri apa ulina kagupu akaso akakagupu maybe muli let's say for example muli silver uzatenga ina ngwicha no kutulamu. As you are pouring there, what are you doing? You are stirring. As you are stirring, some insolubles are going to be formed. What you do after that, you allow it to settle. Then you get it and filter. We're filtering off because we're interested in silver, which is in a solid state. But the one that will pass through the filter paper is sodium nitrate. Are we interested in sodium nitrate? No. What we want is this. So then filter. Filter off.
Number 4 dry.
Number 4 at filter.
Number 4 dry.
Wait. Number 3 first. At filter off.
Filter off.
Very good. Filter off and now. Mona, how can I make sure that silver chloride is free from sodium? It's more like this. Natenga miala zili pamoja. Omuli miala na pangamo zigoro. When I filter them off, is this miala going to be sweet also? Are they going to have zigoro? Okay, you're not understanding. Natenga miala nazifaka muli zigoro. After that, nabuena kamba change chosemo the stones so that the zigoro can be alone. After I filter them off, are the stones going to be sweet? Are they going to contain some sweetness? Very good. How can I make sure that the stones does not contain any sugar? Wash them. You wash them with distilled water and allow them to dry. That is how the samples are formed. And that question when it comes, 4 marks. 4 marks by exam. That's the process. And oh my God, yes, that is the method. And by exercise, I want you to mention each step and include the reagents there. Don't just make it say the two solution. They allow the PB filter off. So filter off the what? Can you read there? I want to write the word. Filter off
the precipitation,
the PPT.
And wash it with distilled water.
And wash it with distilled water.
To remove.
So distilled water to remove, not to remove any amount. So because the question is there, you say filter off the PPT to and wash it with distilled water to remove any amount of sodium nitrate. We're removing sodium nitrate from there. So that's why we're washing it. Then a pure dry sample of silver nitrate, silver chloride dye is formed or forms or is formed. That's those are the 4 steps that you're supposed to mention. By exam, it comes explain how a pure dry samples of silver chloride can be formed. Ziwaza kupasa aya. That's why hapo pama solubilities, insoluble, soluble. Know what insoluble salts are and what insoluble salts are. Hapo paka. Because they won't even give you this. You're supposed to find. Sometimes they will say, given sodium nitrate or sodium sulfate as one of the reagents, can you identify or name the other reagent? After that, write a chemical balanced equation, hence deduce a net ionic equation. Describe how a pure dry samples of maybe barium sulfate can be obtained. 4 marks. That's how the questions come. And cover. Very simple. Let me give you a sample question so they may come up. I don't want to be talking without. Same to you.